All right, let's jump right into it. I am incredibly excited to unpack some truly groundbreaking stuff with you today. We are looking at massive announcements straight out of the FMS 2026 event in Santa Clara, California. For those who follow the space, you know this is the premier stage for the future of memory and storage. And this year, heavyweights Samsung and SK Hynix just revealed the future of AI memory. We're talking about a top-to-bottom reimagining of how hardware is built to handle the frankly insane demands of artificial intelligence. So let's dive into this explainer and see how they are literally building upwards to solve one of tech's absolute biggest headaches. To really appreciate the solution, we've got to understand the headache first, right? Ask yourself, how do we fix the physical traffic jams of the AI era? Think about our current computing systems like a sprawling horizontal city. The AI processor is your bustling downtown core where all the heavy lifting happens, and standard memory, well, that's the sprawling suburbs where the data actually lives. Every single time AI needs to think, massive amounts of data have to commute from the suburbs all the way downtown. And just like a real city, when way too much data tries to commute at the exact same time, you get a terrible grinding traffic jam. That data commute is absolutely killing our speed. Okay, here is our roadmap for today. First, the AI memory bottleneck. Second, 3D architecture with Samsung's zHBM. Third, zNAND for on-device AI. Fourth, scaling up with V10 NAND. And finally, SK Hynix's HBF tech. Section 1, the AI memory bottleneck. You know, as these generative AI models grow into absolute behemoths, their data demands are literally hitting a physical wall. For years, the industry standard has been what we call a 2.5D layouts. This essentially means taking your AI accelerator, your GPU, and placing your high bandwidth memory right next to it on the same silicon interposer. It's kind of like building an apartment complex right next to the downtown core. Sure, it's closer than the deep suburbs, but it still requires a horizontal commute. And as AI models get exponentially larger, even that short trip between the memory and the processor is causing massive bottlenecks. It slows down training, it slows down inference, and honestly, it just burns through massive amounts of power moving that data back and forth. Section 2. 3D architecture, Samsung zHBM. Let's unpack what that little Z actually means here. It stands for the Z-axis. We are officially moving from horizontal sprawl to vertical skyscrapers. Instead of placing the memory next to the AI accelerator, Samsung's zHBM architecture stacks it directly, and I mean vertically right on top of the processor. It completely eliminates the horizontal data commute. The data doesn't have to drive into the city anymore. It just hops into a hyperfast elevator and drops straight down into the processor. By just minimizing the physical distance that data has to travel, you instantly bypass the traffic jam. And the results of this vertical integration? They're staggering. 8 times. That is the maximum system performance boost that Samsung's zHBM provides compared to the previous HBM5 generation, just by cutting out the commute. The AI processor doesn't have to sit around twiddling its thumbs waiting for data to arrive. It processes information exactly as fast as those vertical elevators can drop it down, unlocking 8x performance for massive AI training and inference workloads. But it actually gets better, because fixing that traffic jam also solves two of the biggest existential threats to AI data centers: power and heat. Think about it. Moving data horizontally takes electricity. By stacking it vertically, zHBM hits up to 3 times higher power efficiency than HBM5. And on top of that, usually when you build electronic skyscrapers, things get incredibly hot. But Samsung engineered this to actually reduce thermal resistance by more than 50%. This means these towering memory structures can stay cool and stable, which is just absolutely vital when you're running multi-billion-dollar server farms. What's really crucial here is how customizable this skyscraper is. Because Samsung is stacking this directly on the processor, they introduced a custom IP interlayer. Think of this as a bespoke, highly specialized floor located right between the memory penthouses and the GPU lobby. This interlayer lets clients add custom circuits to optimize the chip for their exact AI tasks, whether that's expanding capacity or tweaking how the accelerator behaves. It's essentially a custom-tailored suit, but for AI hardware. Section 3. zNAND for on-device AI. Now, Samsung isn't just keeping this vertical magic for massive data centers, they are bringing it right into your pocket. Before we look at the hardware itself, let's define the end goal. On-device AI means your smartphone or laptop runs complex AI models entirely locally. It doesn't send your voice or data up to a cloud server to be processed. It does all the heavy thinking right there in your hands. This is the holy grail for privacy and for speed, because there is zero internet lag. The O in Samsung's new zNAND stands precisely for this, on-device optimization. So, to make on-device AI seamless, your phone has to load these massive AI models instantly. Here is exactly how zNAND pulls it off. Step 1. They utilize TSV, or through-silicon via technology. Again, sticking with our building analogy, TSVs are literal high-speed express elevators punched straight through the silicon chips. Step 2. They use 3D packaging to stack 4 to 8 of these NAND chips vertically. Step 3, they've now created a tiny, hyper-efficient skyscraper right inside your phone that delivers massive data loading bandwidth and rapid response times. It's literally bringing data center speeds to the edge. Section 4. Scaling up V10 NAND. Let's see just how high these memory skyscrapers can go when we're talking pure storage capacity. Over 400. Just take a second to visualize that. Samsung officially unveiled their 10th generation VNAND, known as V10BV NAND, and it features over 400 vertical layers of memory cells. 13 years ago, at this very same conference, they introduced the first VNAND. Today, they are stacking data over 400 stories high, just to satisfy the insatiable data hoarding needs of the AI era. And the sheer leap in efficiency from just the last generation is wild. By building past 400 layers, this 10th gen VNAND bumps memory density up by 58% compared to the 9th generation. That means holding over 1.5 times the data in the exact same physical footprint. But it's not just dense, it is remarkably fast. Read and write speeds are up by 45%, and the input-output communication speed jumped 33%. This is a game changer for enterprise storage. Now you're probably wondering, how on earth do you manufacture something so tall and microscopic without it just collapsing or failing? The secret sauce here is wafer bonding and 3-stack technology. Instead of trying to build the memory cells and the surrounding logic circuits all crammed onto one piece of silicon, they build them on completely separate wafers. Then they take these separate, perfectly manufactured pieces and precisely bond them together. It allows them to push the physical limits of height while maintaining absolute structural and electrical integrity. Section 5. SK Hynix's HBF tech. Now, Samsung wasn't the only one dropping jaws at FMS 2026. SK Hynix stepped up, and they are completely reimagining the data neighborhood. Let's look at this new AI memory hierarchy. At the very top, closest to the processor, is SRAM, blazing fast measured in nanoseconds, but extremely low capacity. Next down is HBM, microseconds fast but incredibly expensive. And way down at the bottom is standard high-capacity NAND, cheap, holds everything, but slow, measured in seconds. The gap between HBM and standard NAND is massive. So SK Hynix is sliding a brand new layer right into the middle, HBF, or high bandwidth flash. It operates in milliseconds, acting as a crucial, cost-effective bridge for modern AI workloads. Co-developed with SanDisk, HBF is custom-built for the modern AI data center. While your HBM handles the most urgent data, HBF stores the slightly less urgent but still massive datasets at a fraction of the cost. The specs here are no joke: a blistering 3 terabytes per second transfer speed and up to 512 gigabytes of capacity per unit. Crucially, it uses the UCIe Open Interface. That's a universal connector standard, meaning it's designed to play nice with all sorts of different GPUs and CPUs, fostering a really flexible, open ecosystem for developers. And just to prove they're also racing for the sky, SK Hynix teased their own upcoming enterprise SSD tech, a staggering 375-layer 4D NAND. Slated for early 2027, this architecture boasts a 2.5 times increase in power efficiency compared to their previous gen. It's safe to say the entire industry has definitively decided the only way forward is up. Which brings us to the end of our explainer today. We've seen horizontal sprawl entirely replaced by 400-story memory high-rises. We've seen data elevators punching through silicon and entirely new tiers of memory invented just to keep the AI traffic flowing. But I want to leave you with a thought to chew on. AI models are growing at an exponential, almost unfathomable rate. As we build our memory skyscrapers higher and closer to the processor than ever before, will this 3D revolution finally satisfy AI's endless appetite for data? Or is this all just the foundation for an even wilder architecture to come? Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.